Hey guys, it's Christina Harold here, and today I'm going to talk to you about a topic that pertains to a lot of us, and that is, how do glasses actually work? Is it medicine? Is it magic? No. So the way glasses actually work, the only thing that they do is that they bend light. So in order to understand this, I'm going to first talk to you a little bit about the different eye shapes, and then we're going to talk about the different types of glasses to help correct those vision impairments related to different eye shapes. One very important part of the eye is called the retina, and that is the skin in the back of the eye. And if you've heard of rods and cones, that's exactly where those are. So what our goal is to get light to focus in that exact spot in the back of the eye so that you can see clearly. And if you have an otherwise healthy, functioning eye, we're assuming that the eye does not have any diseases, then bending that light in the correct way should theoretically allow you to see clearly. So let's talk about the ideal eye shape. The ideal eye shape is not too long, not too short, and just the right amount of bend. So when light comes in, light rays come parallel. So they're coming in, and if you picture a side profile like this, they're coming into the eye, and then I'm going to show you a diagram on what happens next. So this is called emmetropia, and this is the ideal eye shape. Not too long, not too short. So the light rays come in, they are parallel, they hit the cornea. So if you imagine this is the side profile we were talking about, this is the skin in the front of the eye. And then once it hits that, the refractive surface is different. So these light rays get bent a little bit, and they're bent in a way so that they exactly fall right in this retinal area, the key sweet spot, which is where we call the fovea. And that eye sees perfectly well because, like I said, it's the perfect amount bendy, it's the perfect length. Another thing you could have is somebody who is farsighted. So if you're farsighted, the light comes in, still parallel. Light's coming in, we're looking at this side profile, it hits the cornea, which is the front of the eye right here. And this light doesn't get bent enough. So either it doesn't get bent enough or the eye is too short because the light is focusing back here. So what we want to do to fix that is we want to give them glasses. And the type of glasses you would give a hyperope or somebody who is farsighted, who sees better far away, you would give them glasses, which is a plus lens. So plus lenses magnify. So hyperopes can burn ants with their glasses. So you give them a plus lens because when the light comes into that lens, it converges the light and it focuses it right on the sweet spot of the retina. And the amount that you would want to focus it is a certain number, and that's what your glasses prescription means. And I will get more into what those units are and how we define that in a different video. But for now, just know that this amount of prescription relates to the length of the eye and the bendiness of the eye so that we can get the light to focus on the retina. So again, somebody who is farsighted, typically without glasses on, would have light be focusing behind the eye because the eye is either too short or not bending the light as much as they need to be. But as we can see with our plus lens, with our glasses, it bends the light just a little bit more to make up for either that short shape or that lack of bendiness, and it focuses right on the retina. Now, when you're someone who's nearsighted, you're myopic, which means you can see better up close than you can far away. And this is exactly the opposite of being farsighted. So the eye in this case is actually a little bit too long, or the focusing power is a little bit too strong. So when the light comes in, hits the cornea, the front of the eye, and it bends it extra so that the light focuses actually in front of the retina. So what we need to do is we need to get a lens to spread that light out a little bit so it focuses where we want it to be. And in this situation, right here, we have light coming in, and we would use a minus lens, which is the opposite of a magnifying glass. It minifies and it makes things look smaller. That's why if you see people who are very, very nearsighted, sometimes their eyes look smaller. So this lens is a minus lens. It's actually thicker on the edges as opposed to a magnifying lens, which is thickest in the middle. This lens has to spread it out a little bit so that the focus point is farther than it would normally be, and it hits that correct spot on the retina so that we can see. So basically, in order to get the right prescription for your eyes, we need to know how short the eye is, where the eye focuses naturally without any help, and then we'll know exactly how far to push the light, either front or back, to get you to see. But there are a couple things I didn't mention, and one of them is units and what they mean. So what are the actual numbers involved, and we're going to go through all that in a future video. The other thing I didn't mention either is a different type of defocus of light, which is called astigmatism, and that is a little more complicated, and it's also a really, really popular word that people throw around, so I want to spend a whole video talking about that, and I will go into that in more detail. The last thing I didn't talk about is something called presbyopia, and that is different from hyperopia. So it's when you have trouble seeing up close as a function of age, and that's something that happens usually around age 40, and it's not the same mechanism as these other types of refractive error. That one has more to do with the muscles and the lens and flexibility and how things work on the inside of the eye, and we're also going to go over that in more detail, but I really want to spend some time on it. I will definitely get to that in a future video, but I hope this video helped you understand the difference between myopia, hyperopia, and emmetropia, which is the ideal eye shape, and if you need glasses, what's exactly wrong with the eye and why you need them. Thanks.